Also. Okay. So our topic today is about blockchain technology. We can next slide. Here's our okay. My name is Abdurrahman. I'm from Bahçeşehir University. Studying computer engineering. Third year, fourth year. I'm going fourth year. Our presentation maximum duration will be 45 minutes, approximately. Next slide. The agenda today will be I will introduce the topic and key concepts. We will go into some key concepts anyone must understand in blockchain technology. I'll also try to discuss some use cases, challenges and concerns, and introduce something beyond cryptocurrency. I'll draw emerging trends, and I will discuss some future outlooks. And finally, we will end it with the conclusion and Q&A session. So for the introduction, the definition of blockchain is basically like a decentralized and distributed ledger system where each it's like a block. Yeah, each block are connected like into a chain. Each block is independent. And all of the blocks are connected one after another into a chain, and they are decentralized, meaning this can indeed enhance the security of the system and make it like immutable, which cannot be mutated afterwards. Also, this cryptocurrency, it is very useful in some of the supply chain management, voting systems. This technology is resistant to fraud and more resilient to being tampered further on. Next slide. So the history of blockchain, this is basically from 1991. We have the pre-Bitcoin era. These two scientists, which is Stuart Haber and Scott Storletta, they first of all they thought of an idea to stamp digital documents to prevent them from backdated and being tampered. Further on, they came up with the idea of introducing Merkle trees into blockchain technology. Merkle trees are trees that can enable more efficient. It is a tree that can encrypt blockchain securely and more efficiently. In year 2008, Bitcoin emerges with Satoshi Nakamoto. He introduces a peer-to-peer electronic cash system. And then in the year 2009, a Genesis block was introduced. The Genesis block is known as block 0. So this is the first block that was discovered with blockchain. The year 2010 it came into early, this was the year of early growth and adoption. And then altcoins and innovations was introduced in the year 2011. In the year 2013, this guy invented Ethereum. And then the year 2017, ICO, which is initial coin offering, was boomed, and some regulatory it was boomed into the blockchain technology. Initial coin offering is an idea where like several want to compete to introduce the first offer the first coin into the system. I will not dive now into the details of this, but maybe later on I will explain it. Between the year 2017 and 2021, the mainstream of the blockchain was more recognized, and now it is now being there is an ongoing development into this technology further on. You can next slide. So the first key concept that you must understand is decentralization. Decentralization refers to the distribution of authority, control, and decision making across multiple participants or nodes, rather than relying on a single central authority. In the context of blockchain, this decentralization plays an important key role. First of all, it has resilience, is resilient to any fraud or any security, trust, you can trust it, and censorship resistance. So censorship resistance, it means that if anyone is able to have a control on each block, so this can resist any censorship or resist anything from being changed, and everyone has the freedom to introduce his own idea, since each block is independent. So this can indeed resist any censorship. You understand what censorship means? No. Okay, censorship means like altering the block. Like means like altering or changing the authority of the block of each block. So the fifth point is ownership and control. Everyone has a full control in the block, and transparent. Transparent means everyone can see each other block. Like this system is very transparent. It is clear. Everyone can see other system, and but this is indeed, this system is very secure. But the blockchain technology enables full transparency and finally innovation. Like as I said, each one has the ability to innovate and create new ideas. Okay, so the second topic, second key concept is cryptography. Cryptography is a foundation component of blockchain technology, plays a crucial role in ensuring data integrity, security, and privacy within blockchain networks. For example, these are the core principles that it contribute to blockchain. First is hashing. Bitcoin uses SHA-256 secure hash algorithm for hashing. Second core principle, it uses digital signatures. Digital signatures are can improve security. Like they are a form of virtual instead of paperwork signature, to make it to authorize this document. Have public and private keys. They are also useful for encryption and decryption. If anyone has previous experience in cryptography, can indeed know this concept. Cryptographic hash functions. There are also some cryptographic hash functions which this can contribute to the blockchain technology. I will not dive deep because this is a topic which overall. This also can give you some a brief understanding of without any zero with zero experience in blockchain. So first of all, this hash function takes a key. Key is an arbitrary size, which can be of different size. So a hash function converts a data of any different size into a specific length, which is known as a hash. So a hash is always the outcome of the hash function is always a fixed size. So it converts a variable size data or key to a fixed size. This indeed is very useful since it can any slight change in one of the keys can indeed warn the user of any tampering that may occur in the future. So also medical trees. Medical tree also was introduced, as I said, in 1992 after the two scientists has developed their idea. This idea is, as I said before, can encrypt blockchain more securely and efficiently. Next slide. So the third key concept here is about consensus mechanism. Consensus mechanism is also an essential component of blockchain. They are responsible for ensuring all participants in a network agree in the validity of transactions and the state of the ledger. So here I have, I will explain the three common consensus mechanisms. First of all, proof of work, proof of stake, and dynamic proof of stake, or dedicated proof of stake. Next slide. So proof of work is simply a mechanism where the one who contributed more work will have the highest priority. So this is the main idea. So here it explains where miners must solve a complex mathematical puzzle to add a new blockchain. So the one who will solve more puzzles and have more work can indeed granted a highest priority. This also prevents double spending, since it shows miners can show computational work, make it economically unfeasible to attack the network. And it is very energy intensive. The security, it is very secure. An example which Bitcoin uses proof of work as its consensus mechanism. Next slide. Proof of stake is another concept is a proof of stake. Validators create and verify blocks. Is another concept where instead of looking for work, it looks for who has the highest quantity of a cryptocurrency, highest amount of cryptocurrency, and they hold and they are willing to stake as a collateral. So the one who has the highest amount of cryptocurrency, they will become and they are willing to stake as a collateral. They will indeed have a more priority in the blockchain system. This can also indeed prevent double spending by using economic incentives. This is less energy intensive, but it is more energy efficient compared to proof of work. Ethereum is transitioning from proof of work to proof of stake. This is an example. The second, or I think the third consensus mechanism, delegated proof of stake. This is the most efficient consensus mechanism, and it is also the most energy efficient consensus mechanism used in the blockchain. It is a variation of a proof of stake where token holders vote for a limited number of delegates who are responsible for validating transactions and creating blocks. So we have several users here, and all of these users, they are vote for number of delegates. This is very useful in democracy, like democracy. So this can maintain security through a limited number of trusted delegates who are incentivized to act honestly. So this picture can summarize the main idea of this concept. An example of EOS and the Tron, which is known as TRX, uses delegated proof of stake as their consensus mechanism. Next slide. So we have our use case. I'll talk about some of the cryptocurrencies invented. One of the most famous things is Bitcoin, which was created by anonymously intelligent, which is Satoshi Nakamoto in 2009. It's one of the most well-known cryptocurrency, Ethereum, which is launched in 2015 by Vitalik Buterin, which is introduced the concept of smart contracts. Which also decentralized apps also can utilize the. I will explain smart contracts in more details in the next slide. Ether is native currency, and we also have some Dogecoin. Dogecoin is a cryptocurrency invented by Elon Musk. We have also Tron and Ether. I explain smart contracts here as a second our use case. So basically, it is a contract which it's like a digital contract, which is a self-executing contract in terms of agreement between the buyer and a seller, which is directly programmed into lines of code. So that the normal contract is automatically programmed into some line of code. This is very useful, which can reduce some paperwork, and they run on blockchain network, and they can automatically execute and enforce terms of agreement without the need for intermediaries like banks, legal systems, or insurance companies. This also can visualize how it works. Next slide. So our third use case is about supply chain management. Blockchain can greatly vastly improve the supply chain management, since it can first point, it can immutable record keeping. Blockchain distributed ledger record every transaction in a supply chain, which can create an immutable and tamper-proof history. Second benefit of blockchain to the supply chain management is that it can enable real-time tracking of their supplies. How? Because by using the Internet of Things, devices such as RFID tags and sensors can be integrated with blockchain. These devices can provide real-time data on the location and the condition of goods in transit, enhancing the supply chain visibility. The third benefit of blockchain to the supply chain management is that it can enable transparency. Multiple stakeholders in the supply chain, including manufacturers, suppliers, logistics, can access the same blockchain data. This transparency reduces disputes, errors, and delays, by ensuring everyone has a consistent view of the supply chain. Next slide. So also it is very useful in efficiency gain. So as I said, it can reduce paperwork and make it faster settlement. How it reduce? Because smart contracts can as I discussed in the previous use case, can automate the payment processing and custom documentation and other administrative tasks. This can speed up the process and lower the risk of errors. The second point is faster settlement. Blockchain enables faster and more secure cross-border transaction, which can automatically trigger payments when the pre-default conditions are met, like successful delivery and so on. Next slide. Some of the real-world examples that of the supply chain management that uses blockchain is IBM Food Trust. IBM Food Trust uses blockchain to enhance the traceability of food products. It allows consumer to scan a QR code on the product and view its journey from the farm to the store. This transparency helps identify any source of foodborne illness or ensuring the quality of food products. The second supply chain that uses blockchain is Walmart and Hyperledger Fabric. So Walmart uses a Hyperledger Fabric, which is a blockchain platform to track the movement of pork in China. This system reduces the time to track the trace of origins of pork from weeks to just seconds, which can improve the food safety, and it is very useful for the Muslim community, I think. Challenges and concerns related to blockchain. First of all, it is scalability, security, and regulation. Scalability, because as I said, blockchain is it's very hard to scale to scale the since many users can contribute to it and contribute to the technology, and it can lead to sudden expansion of the network. So it is very hard to ensure the scalable system. Security, because any person in the decentralized system is very vulnerable to attack. Therefore, security is an ongoing development on blockchain technology, and regulation. Regulation is also one of the challenges witnessed in the blockchain technology. Blockchain beyond cryptocurrency, healthcare organization often struggle with securing patients' health records. So blockchain enhance the security by encrypting and decentralizing these records. It is very useful in drug system tracking, which can ensure or track the drug that is transferred to the patient, and can indeed improve the efficiency of healthcare organization to perform this task. Second slide. So I'll discuss one of the emerging trends in the blockchain technology nowadays is the tokenization of assets. So tokenization of assets is converting real assets into a digital form. Like a real estate, art, or even stock. Some of its benefits can increase liquidity, accessibility to a global market, reduce barriers to entry. So there are two types of tokens, fungible token and non-fungible token. So NFTs, I think, is very well known in the web, especially in Web 3.0, the type of digital asset that represent ownership or proof of authenticity, which cannot be. It is the opposite of fungible, which cannot be interchanged on one-to-one basis. Each NFT has a distinct value and a specific attribute, and they are non-fungible. These assets represent ownership or proof of authenticity of any item or piece of content. This graph also visualizes the tokenization of assets, which factory building, car, for example. Can you? No, the previous. Okay, so these are all real assets, like a factory, for example, building, park. They all agree on an ownership certificate, and they are converted to a digital asset into the web platform, which can be automatically used by the blockchain technology system, and can finally this blockchain technology system can utilize the data in the web platform to generate a secure token, which can indeed, as I said, increase the liquidity of all of these assets and make it more accessible to a global market. Next slide. So finally, the future outlook of blockchain technology, it reflects many scientists nowadays, we are trying to make ongoing efforts to balance the security, scalability, energy efficient, and decentralization. As I said, the one of the most energy efficient consensus mechanism, which is delegated proof of stake. It is also not one of the most efficient consensus mechanism. So scientists always are trying to make an ongoing development of it. They use a hybrid consensus mechanism, which includes the combination of proof of stake and the proof of work to achieve speed, security, and decentralization. Proof of POA, which is proof of action, but some books they say proof of action, but the same as proof of work. So second improvement is future consensus mechanism, which continue into novel consensus mechanism, include proof of space-time, proof of history. Some scientists like trying to make variations of proof of work and proof of stake to address the current limitations and open new possibilities of blockchain technology. So finally, the conclusion of this presentation is that blockchain represents a transformative force with wide range of applications. It can, as I said before, it can enhance the supply chain management, the healthcare industry, and it can improve our organization more efficiently. And as I said, we also understand some core principles that stay open to future possibilities for harnessing the full potential of the blockchain technology. So anyone have any questions or